Okay, so if you've ever written a little bit of Python, you know how to give it orders, right? You tell it to do step 1, then step 2, then step 3. But what if your code could do more than just follow a list? What if it could actually, well, think? What if it could make its own decisions based on the situation? That's what we're going to get into. We're going to go from writing simple scripts to building smart programs. Let's do this.
Just look at the difference here. On the left, you've got a script that's a perfect soldier. It runs from top to bottom the exact same way every single time. It's reliable, for sure, but it's also kind of dumb. Now, look at the code on the right. This code can react. It asks a question, hey, did the user pick A? And then it does something different based on the answer. And that is the huge leap we're talking about, from just giving commands to actually creating logic.
So, how do we actually give our code that power to choose? Well, it all boils down to one of the most important ideas in all of programming. It's called conditional logic. This is, for all intents and purposes, how we give our programs a brain.
And before we even write a single line of code, just think about how you make decisions every day. You do this constantly without even realizing it. It's a simple test, right? If this thing is true, I'm going to do this. Otherwise, I'll do that other thing. This exact same intuition is the absolute heart of what makes code smart. And here's what that looks like in Python. It's super readable. We start with an if. The code checks that first condition. If it's not true, it just moves on to the elif. And yeah, elif is literally just short for else if, and it tests the next condition. And if nothing else matches, the else at the bottom is the final safety net that catches everything else.
Now, this is the really crucial part to understand. Python reads this from top to bottom. And the very second, the instant it finds a condition that's true, it runs that code block and then, and this is the key, it completely ignores the rest of the chain. It just jumps out. It doesn't even bother looking at the other elif or else statements. Only one path gets chosen.
All right, so our code can make decisions. That's awesome. But what about all those mind-numbing repetitive tasks? Well, that's where our next major tool comes into play, loops. This is how we unlock real automation and save ourselves a ton of work.
I mean, who doesn't, right? Just imagine having to copy and paste the same line of code 1,000 times. There's actually a core principle in programming called don't repeat yourself, and loops are the magic wand that makes that principle possible. Check this out. It's so clear when you see it side by side. On the left, if you wanted to print hello 100 times, you'd need 100 lines of code. It's painful. But on the right, with a for loop, you just change that 5 to 100 or to 1,000,000. One tiny change lets you do 1,000,000 times the work. That's not just efficiency, that's a superpower.
So you've got two main kinds of loops in your toolkit. You'll want to use a for loop when you know exactly how many times you need to do something, like go through every single item on a shopping list. But you'll use a while loop when you need to keep going until a certain thing happens, like in a game that keeps running until the player runs out of lives.
Okay, here's a huge piece of advice for while loops. You see that little line there, count plus equals 1? That is everything. It's your escape hatch. If you forget that line, count will always be less than 5, the condition will always be true, and your loop will run forever, totally crashing your program. You have to give your while loop a way out.
Okay, we can make decisions and we can repeat actions. Now it's time to learn how to package all that smart logic into nice, tidy, reusable tools. This is where functions come in, and trust me, they are a total game changer for writing clean and powerful code.
So what is a function? It's basically a mini program that you get to create. You give it a name, you teach it how to do one very specific job, and then, from that moment on, you can just call it by its name whenever you need that job done. You never have to write the code for it ever again.
Let's look at a really simple one. You use the def keyword to define it. We've named this one greet, and we've told it to expect one little piece of info, which we're calling name. Then, later in our code, we just say greet Amit. The program finds our little tool and runs its code using the info we passed in. It's simple, it's clean, and you can use it 1,000 times.
Now this is something that trips up almost every beginner, so let's make it super clear. Print is for us, the humans. It's like shouting something out loud so we can see it on the screen. The program can't really do anything with that. But return is like passing a secret note back to the program itself. It hands a value back that the code can then catch, save, and use in the next step. One is for showing, the other is for using.
Okay, this is it. We have our 3 core building blocks. We've got conditionals for making decisions, loops for automating things, and functions for organizing our code. Now let's see how they all snap together just like Lego bricks, to build a real working application.
And a simple calculator is the perfect recipe to see how this works. I mean, look at the steps. First, you define your tools. You make an add function, a subtract function, and so on. Then you build the engine to make it run continuously with a while loop. And finally, you give it a brain, using an if-elif structure to check what the user wants and call the right tool for the job. See? It's everything we just learned.
And this is the heart of the machine, right here. You've got this loop that runs forever, constantly asking the user for what to do next. Then inside that loop, you have your if-elif block, acting like a traffic cop, looking at the user's choice and directing the flow of the program to the right function. It's a perfect combination of loops, conditionals, and functions all working together.
And when you really boil it all down, that's what it is. 3 simple ideas. You've got conditionals to make choices, you've got loops to handle repetition, and you've got functions to keep it all organized and reusable. With just these 3 core concepts, you have the fundamental toolkit to build almost anything you can think of.
So there you have it. In just a few minutes, we've unlocked the secrets to making code that's not just obedient, but intelligent, efficient, and well-organized. You now have the power to do more than just write a script. You can create real logic. So the only question that's really left is, what are you going to build with it?